Hi, my name is Sai Ranjantra, and this is my submission for Comprehensive Interrupt-Based Sense ThinkAct System. It's a machine safety interlock on Arduino Uno and Tinkercad. The machine only runs when guard door is shut, the light curtain is unbroken, and both start buttons are held, so the both hands are clear. So starting on, looking at the circuit, as you can see on the left side, there are 5 push buttons: start A on D9, start B on D10, light curtain on D11, emergency stop on D2, and reset on D3. This light switch is guard door on D8, and every input is input pull up, so there are no pull down resistors anywhere. Pressed reads low. Uh, for the output section, the green LED on D5 is running, the red LED on D6 is for fault, yellow one shows state by blink pattern, piezo on D4 and potentiometer on A0 is speed set point. The key grouping over here is D8 to D11. Those are PB0 and PB3, so all four share a single pin change interrupt vector. Now let me press start simulation, and now let me click the guard switch closed. Sense think act. Sense the switch change over here. Check the guard is closed and both buttons are released. Moved to safe idle. Notice it prints all 4 inputs, not just the one that I moved. That's because pin change gives one vector for the whole port and no edge information. So the handler has to read the PINB register and work out what changed from the snapshot. Let me hold start A button. That's the anti-tie down rule. The second start button has to arrive within 500 milliseconds of the first. Someone taping a button down registers it far earlier, so the window expires and start is refused. And it's the transition that needs both interrupt types. Pin change detected the press and the timer measured the gap. Now let me press reset. Yes. Now let me tap on the light curtain. So now the curtain is broke. Just give me a second. Yeah. Now the curtain is broken. Instant fault. That stop happened inside the pin change ISR with a direct write to PORTD before the debounce filter had any say. Because debounce here is 40 milliseconds and 40 millisecond delay on safety stop is actually a defect. A false stop is safe, a late stop is not. That asymmetry is the main design decision in this project. Now let me again press reset. And now let me press emergency stop. Emergency stop is a separate vector, int0 on D2 on falling. The handler is 3 lines basically: clear the run output, set a fault code, and queue an event. No delay, no serial, and no loops. The message you were seeing earlier was printed by loop, not the ISR serial.print. The serial.print blocks about a millisecond per character once the buffer fills, which is totally unacceptable in a safety handler. Now let me try to hold start A while holding, and I'll press reset again. Yep, reset refused because the control is still held. Yeah, now it clears. Now let me press all guard switch and the buttons start A, B, and light curtain rapidly. That's a burst of pin change events. Peak per tick has gone up, but dropped is still 0. The 16 entry ring buffer absorbs it, and the loop drains faster than interrupts fill. Now let's drag the potentiometer. And the speed set point tracks the pot. analog sampling in the period paths, never inside an ISR, because analog read blocks for about 100 microseconds.